Good morning, students. Today we are going to see the last subtopic of the Unit 1, that is carbon cycle. Introduction to the carbon cycle. Carbon is the fundamental building block of life found in plants, animals, microorganisms, food, and our own bodies. Though it makes us less than 1% of Earth, atmospheric carbon compounds have played a crucial role in warming the planet enough to sustain life. The carbon cycle is the natural movement of carbon through ecosystems involving biological, geochemical, and soil components. I will explain to you what is biological, geochemical, and soil components in the next slide. Okay, so what we need to understand is that this carbon cycle is a predominant consideration, okay, in order to reduce the climate change. Human activities, particularly the fossil fuel use, are disrupting this natural process and raising environmental concerns. As we know, we have been importing and even we are exploring the fossil fuel from our India itself. Just imagine the Indian population is almost 140 billions, I mean 140 crores. Okay. The automobile which has been used inside the country is very enormous. Okay, so how much amount of energy, I mean, the fossil fuel is needed? Okay, obviously the fossil fuels, if you go for the processing like fractional distillation, okay, it will have been converted into, as we know, petrol, diesel, bitumen, naphtha, and also the gases like propane, butane, and so on and so forth, right? So these are all nothing but hydrocarbons. So the carbons which are present when you try to burn it in your what you call through automobile, okay, what will happen actually is a combustion takes place, so that you will get a carbon dioxide and carbon monoxide, which has been a predominant factor that will increase the carbon footprint of the earth, not only the industrialization, even for the automobile. So because of the urbanization also the carbon increases. So please try to understand the importance of reducing the carbon cycle in the atmosphere. And coming to the importance of carbon in Earth system, carbon's presence in the atmosphere, ozones or soils and living organisms helps regulate the temperature and sustain life. So if you think like that, I mean, because of the carbon only, this all happens. Okay, yeah, we should not avoid the carbon also. Okay, that should be a natural one. That a carbon present in the atmospheres, ozone and soils and living organisms helps regulate the temperature and sustain life. So it is also important, but at the same time, it should not go beyond the certain level. Okay, carbon dioxide in the atmosphere, although only about 0.03% is a key greenhouse gas, preventing excessive heat loss to space. As I told you, if there is an absence of carbon footprint, I mean greenhouse gas, obviously the earth has been cooled down to minus 18 degrees Celsius. That's what we have seen in the previous gas. The carbon cycle operates continuously, moving carbon in large quantities between pools while maintaining a general balance. This stability can be disrupted by significant changes in carbon input or removal, such as those caused by the human activity. Components of the carbon cycle: biological component, geochemical component, and soil component. Just now I told you, I will explain about these three components. Biological component, the carbon component involving living organisms from plants to animals and decomposers. Okay, carbon movement involving living organisms. What are the living organisms? Okay, like plants, animals, okay, even humans. Okay, they're all living organisms. Carbon movement involving the living organisms from plants to animals and the decomposers. So the component of carbon cycle is biological component. This is a natural one. Geochemical component: carbon exchange through rock formation, okay, erosion, volcanic activity, and ozonic process. Let's say the carbonate in the rock has been converted to carbon dioxide. Carbon exchange through rock formation, erosion, volcanic activity, and ozonic process. Okay, so this is also a natural one. Soil component: organic matter stores large amount of carbon. Okay, often stable for long periods. Okay, so this all is a natural cycle. So the human-made activities also increase the carbon footprint. Okay, so organic matter stores large amount of carbon, often stable for long period. This component acts as carbon pools, functioning as storage, that is sink or sources. This component acts as a carbon pools. That means is a source, functioning as a source. In a natural state, these poles remain relatively stable through dynamic equilibrium. Understand the word through dynamic equilibrium. Okay, so it's a natural state. Okay, if you that's why I told used to say if they don't disturb the environment, obviously it will could able to regain its position by natural whatever there is happening. For example, volcanic eruption, earthquake. Okay, this will naturally happen. Okay, obviously it will regain its position, but at the same time if you because of the human activities if it is going above the certain level it could not regain by its position. That's why the people have been talking about sustainability. I already told you. Okay, coming to the carbon in the atmosphere and ozones, the atmosphere contains about 500 to 700 billion tons of carbon, mostly as carbon dioxide. Okay, the atmosphere contains almost 500 to 700 billion tons of carbon, mostly as carbon dioxide. Just imagine by nature. Okay, the surface ozone layers also hold a similar amount, interacting directly with the atmosphere through gas exchange. Okay, so is almost will have a same amount. The surface ozone layers also hold a similar amount in billion tons of carbon, interacting directly with the atmosphere through gas exchange. This interaction allows the ozone to absorb atmospheric carbon dioxide, moderating the climate change input. However, ozone capacity for absorption is limited and excess carbon dioxide can contribute to acidification. Okay, so even though the ozone, surface ozone have a similar amount and then interacting directly with the atmosphere through gas exchange, if you add add on carbon dioxide into the atmosphere, the ozone capacity for absorption is only limited so that as I told you the carbon dioxide and the water which is present in the thing will form a carbonic acid. Okay, so that is why that's what they are saying here. Excess carbon dioxide can contribute to acidification. Plants store roughly 500 to 700 billion tons of carbon in their biomass. Just imagine how much million tons of biomass has been tons of carbon has been stored by the plants. Through photosynthesis, plants fix atmospheric carbon dioxide into stems, roots, and leaves. Okay, that we know already. The photosynthesis is doing the process. It will take up the carbon dioxide and release the oxygen. Animals include humans store only 1 to 2 billion tons of carbon. Underline the word only one. So imagine the plants store almost 500 to 700 billion tons of carbon in their biomass, whereas the animals can store, animal and including humans can store only 1 to 2 billion tons of carbon, small compared to the plants and soils. Carbon small compared to the plants and soils. The food chain transfer carbon from plants to animals, eventually returning it to the environment through respiration and decomposition. Soil as a carbon pool. Soil holds around 1500 billion tons of carbon, twice as much as planets. So the imagine compared to the plants, the soil holds almost 1500 billion tons. Is only 700, almost 750. Just consider. Okay, 1500 billion tons has been stored by the soil. Much of this carbon is stable, locked in organic matter for decades or centuries. Soil carbon is released through microbial decomposition, erosion, and land use changes. Maintaining soil carbon is critical for both climate regulation and agricultural productivity. Okay, maintaining the soil carbon is critical for both climate regulation as well as the agricultural productivity. Deep ocean and rock carbon stores. So the deep ocean contains about 36,000 billion tons. Just imagine how much the plant contains, how much the soil contains, how much the deep ocean contains about 36,000 billion tons of carbon, making it a major long-term carbon pool, that is a carbon source. Exchange between the deep ocean carbon and the surface occurs slowly, often over centuries. So there is a surface water and the deep ocean will have a difference in amount of carbon present. So obviously the transfer will take place, but it is very slowly, often over centuries. That's what they mean. Rocks, particularly limestone, shows an immense 75 million billion tons of carbon far exceedingly other ports. Okay, so imagine rocks, particularly limestone, store an immense of 75 million billion. Okay, so it's not only billion tons, it also million billion tons of carbon. Okay, for exceeding the other ports. So which is having a higher rock, soil, plant, or animals, plants, animals, humans. Okay, so the rock is having a million billion tons of carbon for exceeding other ports, far exceeding the other poles. Underline the word far exceeding the other poles. Okay, this geological carbon is largely stable but can be released through the volcanic eruption and weathering. Is largely stable. This geological carbon is largely stable but can be released through the volcanic eruption and weathering. That's what they mean. Okay, photosynthesis and carbon fixation. Photosynthesis is a primarily biological process moving carbon from atmosphere into living organisms. Plants converts carbon dioxide into glucose, building plant tissues and storing carbon into stems, trunks, and roots. Plants convert carbon dioxide into glucose and building plant tissues and storing carbon in stems, trunks, and roots. That's why in the industrial area, the people have been asking to put a lot of plantation because, excuse me, because when you have a chimney, chimney through the chimney lot of carbon dioxide emission takes place. Let's say when exhaust gas contains a large amount of carbon dioxide, this particularly can be reduced by the plants which has been surrounded because the carbon dioxide will be taken up. Okay, plants convert carbon dioxide into glucose, building plant tissues and storing carbon in stems, trunks, and roots. In oceans, plankton and corals fix dissolved carbon dioxide into calcium carbonate for shells and skeletons. So in oceans, plankton and corals, the coral reef, okay, fix dissolved carbon dioxide into calcium carbonate for shells and skeletons. When these organisms die, they remain sink. There is a source locking carbon away in sediments over millions of years. Now, herbivores. Carbon transfer through food chain. Herbivorous consumes plants, transferring carbon into animal biomass. Let's say you have herbivorous. Herbivorous means it will eat only the plants. So transferring the carbon which are present in the plants, transferring carbon into animal biomass. Okay. So carnivorous acquires carbon by eating herbivorous. So it's a transformation how it takes place. Okay, the plants contain carbon. Okay, the herbivorous consume plants, transferring carbon into animal biomass. Carnivores take up the herbivorous, so again the carbon chain takes place. Carnivores acquire carbon by eating herbivores, creating a chain of carbon transfer. Excuse me. When animals die, decomposes returns carbon to the soil and atmosphere. The time frame for carbon cycling in food webs can range from days to hundreds of years. Decomposition and long-term storage. Decomposition releases carbon as carbon dioxide through microbial respiration. Some organic material resists decay, contributing to long-term soil storage, carbon storage. Some organic material resists decay, contributing to long-term soil carbon storage. In aquatic systems, decomposition of plankton can lead to deep-sea sediment formation. Okay, so over geological timescale, these sediments can form fossil fuels or carbonate rocks. So decomposition and the long-term storage which has happened by the natural means, that's what they have been discussing here. Geochemical carbon movement. Deep ocean currents slowly circulate carbon, bringing deep stored carbon to a surface after centuries. As I told you, the surface water and the deep ocean will have a difference in concentration of carbon. Obviously, there will be a transfer takes place from the deep ocean to the top. Okay, but it's very slow and it will take a centuries. Okay, that the time period may be a hundreds of years. Volcanic eruptions release carbon dioxide trapped in rocks, influencing atmospheric composition over long time scales. So if you go to near Indonesia, volcanic eruptions are very common. Okay, so a lot of it will release a lot of carbon dioxide trapped inside the rocks, which are trapped release carbon dioxide trapped in rocks, influencing atmospheric composition over long time scales. Okay, so it will increase the carbon dioxide which is present in the atmosphere, influencing atmospheric composition over long time scales, over a long duration. Okay, weathering of rocks releases carbon dioxide from carbonates into atmosphere. This process operates far slower than biological exchanges but are critical for Earth carbon balance. earth carbon balance we need to consider. Okay, otherwise the sustainability could not be maintained. Okay, fossil fuels from over millions of years from buried organic matter under heat and pressure. Fossil fuels form over millions of years from buried organic matter under heat and pressure. So how the fossil fuels has been created? Okay, because of the organic matter which has been buried under the heat with a very high pressure and heat. Coal, oil, and natural gas are the major carbon-rich energy sources. Okay, so as I told you, the crude oil, when you separate the gases, natural gas, I mean the what is called the gas, propane, butane, methane. Okay, these gases, and along with that, the crude oil, the natural gas also will comes out. Okay, the coal, oil, and natural gas are the major carbon-rich energy sources. For industry, mainly they use a coal-fired boiler. Just imagine. So obviously, the carbon when they fire the coal, the carbon dioxide will be produced. So that will increase the carbon footprint. Okay, the carbon cycle is supposed to be maintained in the atmosphere. Otherwise, that will lead to the global climate change. Burning these fuels releases stored carbon rapidly, overwhelming natural absorption process. Human relies on fossil fuels has accelerated atmospheric carbon dioxide accumulation since the industrial revolution. That's what I told. Human impacts on the carbon cycle. Annual fossil fuel use releases over 5 million tons of carbon into the atmosphere. Just imagine how much ton of billion tons of carbon has been released because of the fossil fuel. Annual fossil fuel use releases over 5 billion tons of carbon into the atmosphere. Okay, deforestation removes carbon sinks. Okay, removes carbon sinks. So, what you call it, and releases stored carbon from vegetation and soils. Deforestation. Okay, deforestation, what will happen? Removes carbon sinks and releases stored carbon from vegetation and soils. Okay, so the deforestation is not only convert the carbon dioxide into oxygen, it also removes carbon sink. That means is a and releases stored carbon which is present in the plant from vegetation and soils. Okay, it's a both the way it is getting affected. Hope you understood. Okay, so because of the not plantation has been taken, is not only converting the carbon dioxide into oxygen, at the same time, it has started to release the carbon which is present in the plant. Okay, land use changes such as converting forest to farmland disturb the soil carbon pools. So one or other way it has been related. Okay, so the deforestation again it has been connected to soil. That soil carbon pools are also getting affected. So don't disturb the natural things. Okay, the deforestation and all is not encouraged. Okay, because we are not plant, we are just putting a plant very rarely. This plantation by natural means it has been occurring. Okay, if you plant it 10 plants and then cut 8 plants is meaningful. 2 plants is still has been carried out by you. But at the same time, if you're not at all doing any plantation and then simply cutting the plantation, just imagine that means you are going against the nature. Whenever you go against the nature, okay, obviously you will need to pay the amount to the what it called for your action. So what I mean, you understand. Okay, so that means the global climate change is the action of what we did during the industrialization process, knowingly or unknowingly. Okay, but knowingly we came to know that the carbon footprint is causing the things for the last 40 years, but still what is the action they have taken? So until I can say until 1980s, the throughout the globe, the we is safe for the human to survive and even for the other plant species. But after 1980s, is a large what you called we are not at all taking care of the carbon footprint. Okay, in a very serious manner. Obviously, we just talk, but we didn't take any steps actually. But however, there are I could not say they didn't take any step, but at the same time they are taking a process progress very slow. That I can say. Okay, so very slow. Okay, because of that, the countries a few because of the action taken, the countries they claim they will stop the carbon footprint. Okay, in 2050 to 2050, like China and India, they have been zero discharge. Okay, so zero carbon discharge. Just imagine. Okay, these are the things need to be taken in early steps also. Now they have been trying to find it. Otherwise, after 2050, if the same the condition prevails, then the Earth could not be a safe planet to survive for the human as well as the other species. Okay, that's why the people like Elon Musk have been trying to move the people from this planet to the other planet. Okay, destroying this planet and going to the other planet is not advisable. Okay, we can go for another planet and try to explore as a secondary source, but at the same time, we should safeguard our plan. What do you call it? We should not affect. At the same time, we should be very careful on disturbing the environment or the planet. Okay, observing carbon changes, the Mauna Loa Observatory has measured carbon dioxide levels since 1958, providing clear evidence of rising concentration. So this observation has been accepted, okay, by many people. That's why they mentioned here. Observatory has measured carbon dioxide levels since 1958. So the increase in concentration has been clearly visible through his observation. Antarctic ice cores reveal historic carbon dioxide levels, offering contrast for current changes. Ozones and plants absorb some emissions, but about half of human release carbon remains in the atmosphere. Ozone and plants absorb carbon emission, but about um, half of human released carbon remains in the atmosphere. So even though it could be able to withstand, okay, regain its position, the ozone and plants by absorbing the carbon dioxide released by the human, but still half of the carbon which is released by the human is still remain in the atmosphere. That's what they mean. Okay, so the ozone and plants absorb some emission, but about half of the human released carbon remains in the atmosphere. This imbalance leads to a net increase in atmospheric carbon dioxide over time. Global warming concerns. The extra carbon dioxide strengthens the greenhouse effect, trapping more heat and warming the planet. Some plant growth may benefit from higher carbon dioxide, but water and nutrient limitations can offset gains. Some plants growth may benefit from higher concentration carbon dioxide. So if you have higher carbon dioxide, the plant growth, okay, I mean the photosynthesis will go. But water and nutrient limitation can offset the gains. Warming may accelerate soil decomposition, releasing more carbon and destabilizing the storage. So because of the warming may accelerate the soil decomposition. Just imagine how much billion carbons are present, billion tons of carbon has been present in the soil. Warming the may accelerate the soil decomposition, releasing more carbon and destabilizing the storage pools. This feedstock can further intensify the climate change. So in summary, the carbon cycle is a very important earth process balancing carbon storage and release. Human activities have significantly altered this balance, increasing atmospheric carbon dioxide levels. Continued monitoring and understanding of carbon flows are essential for climate action. So, you should understand the process, how much is the carbon present in animals or plants or the humans, how it has been interacted, how much is the carbon present in the surface of the ozone and underneath the sea, how much is the amount of carbon which has been present in the soil. Okay, hope you understood this lecture. Definitely, it will be helpful to understand, see the carbon cycle. Okay, not only in terms of the perspective of human anthropogenic activities, but also by natural means, by vegetation and so on and so forth. Reducing emissions and protecting carbon sinks like forests and soils are critical for restoring the balance. Long-term sustainability depends on managing both human impacts as well as the natural process. It's not only the carbon cycle has been changing because of the human impact, and it's also by natural process it has been occurring. The earth could be able to regain its position if there is a certain level of human impact is there, but if it exceeds, obviously it will not regenerate back. So the sustainability, that's why the people have been keep on talking about the sustainability, so in order to avoid this side of the uh, indirect, the impact of human activities. Okay, with this note, I stop it here. I believe that hope you understood the first topic very clearly. Okay, if you have any doubt, just come and knock me during face-to-face section. With this note, I stop it here. Thank you.